Good afternoon, everybody. We'll be starting in just a minute. Let me set this up to share some things. Okay, we will go ahead and get started. I've got 3 clocks in front of me, 2 of which says it's 4, 1 of which says it's 3:59. That's close. Today's topic is File I/O. It'll be the first of 2 lectures on writing to and reading from files rather than the keyboard and the screen. But before we get to that, I want to go over a couple of things that might help with homework and the upcoming major programming assignment, which will be released this week. If you pay attention to the majors class got assigned a program to write a game last Friday. We will not be doing that as their assignment requires the use of Python dictionaries, which we won't cover for another week or 2 in this class, so it would kind of be unfair to give you that particular program. So we'll talk on Wednesday about programming assignment number 1 for this section. In the meantime, you've got homework number 5 out. It is due on Wednesday night. There's a couple of things that I'm not going to give you any direct answers or hints, although I've helped a number of students already who asked questions, and I'm happy to help others as well. But I want to talk about the general approach for developing programs, and I'm not spelling werewolf, so let's try to get this correct. Some general tips for developing software, things you should do. There is a rule that we try to emphasize over and over. I definitely have not emphasized it enough so far in this class, so I'm going to do this. The rule is test as you go. When you are writing a program that uses multiple functions, what you should do is break it out. Now, with the homework, we've broken it out some for you by telling you what the functions are. Write one function at a time. Write the function, test it, make sure it works before you move on and write other functions. The reason being that if you write multiple functions and then try to test them all for the first time together, you're going to get weird errors and you're never going to be able to debug them properly. It's going to be a royal pain. I mean, never be able to is harsh. It will just be a lot harder and a lot more work. So what we want to do is write a function, test it, know that it works, and move on. Now, I will tell you, when we get to test 2 in this class, there is a multiple choice on test 2 that's always, I've given it every semester. It's kind of a freebie. And the question is, what is the best method for developing software that uses multiple functions and becomes more complex? And we only give you one answer. It's a multiple choice question where we only give you one answer. Test as you go. Yeah, it's free points. Okay, fine. But it's that important a thing. So what I want to do is work through something that was similar to your lab last time. Suppose you're assigned to write a program that prompts the user to enter a string of names of dogs, a string of names of cats, a string of names, whatever. You have to find the number of letters in each name and then sum up the number of letters and use functions to do this. Let's write and test each function as we go. So what we will do is we will go to PyCharm. I will clear this console and bring up another one. Just testing some of the code we're going to be using in a few minutes. So we have something like this. We know we need a function, build name list. This is where the user enters the names of dogs, cats, birds, pets, whatever, and we return the list. So this is going to be the function where we find the length of each name. This is going to be the function where we add them all up. And then we have our main program, and our main program really is very, very simple. And as you become more advanced in computer science, your main programs will really look like this, right? Your main program will be call a function, call a function, call a function, print a result. Boom, we're done. Okay, so let's talk about build the name list. Now, the name list says we're just going to ask the user for a list of names, enter stop to stop, and we're going to build a list. So we start with an empty list, okay? And now we're going to say name equal input, enter a pet's name, enter stop to stop. Okay, this is going to come in as a string, so we're fine. While name not equal to stop, name list dot append name. And now, when we're done, all we're going to do is return name list. Now, I'm not going to worry about whether we do uppercase or lowercase or whatever, right? We return a string, so I don't have to worry about anything converting to integer or anything like that. So here is my function. Now I need to test it. Okay? No syntax errors, so now I just need to test it. So I'm going to say names equal build name list. Now notice that build name list took no arguments. There's no argument, there's no parameter because nothing's passed in, and that's perfectly fine. Okay, so this is just code that tests my function. Enter a pet's name, enter stop to stop. Well, my current dog's name is Doug because my daughter liked the movie Up. My daughter's dog's name is Lizzie. Okay. Guess what I forgot? This is why we tested. I didn't get another name. Okay, so this is why we test this function. Okay, so let's retry this. Let's kill that. Start over. Here's my function. Hold on, sorry. Went too far with my copy. Okay, now names equal build name list. All right, let's see if this works. Okay, Doug, Lizzie, Remy, stop. Now, what's the value of names? Indeed, I now have a list of names that has 3 dog names in it as strings. So I can conclude at this point that this function works well enough for me, right? That's a simple test. It stopped when I typed stop. It entered the names. It created the list. Everything appears to be working. So now I know that build name list works. I don't have to worry about it anymore. Now I can pass in this list of names and I can find the name lengths, right? We know that this is a list of strings and the length of each string is given by len, L-E-N, of string, okay, of the string. So we know that. I'm going to build a list of lengths. THS, I can spell it, equals, and I'm going to start with an empty list. For I in name list, range. I could do this a couple of different ways. Let's try it this way. For I in name list, I'm actually just going to take the individual name. List of lengths dot append length of I. Return list of lengths. I could spell lengths, it would be easier. Okay. So now I just have to bring that code down into my Python console. Now, we already know I have the list names, which has the things I entered. So now I'm going to say lengths equal list of lengths. Now it's find name lengths. Find name lengths of names. What does the list lengths now hold? It should have a list of integers 4, 6, and 4. And yay, verily, it works. So now I know that I have a function that can take in the list of names. I know that I have a function that can calculate the length of each name. And now I just have to write the function that sums all the lists. Okay, and I'm going to do that in a parameter called length list. And so now all I have to do is initialize sum to 0 for I in length list sum plus equals I, return sum. Okay, now I copy that down to my console and execute it to make sure I don't have any syntax errors in it, like typing or things like that. And that didn't have any syntax errors. So now I just have to test this out by calling. I had the variable lengths was the list, so I need to pass it. So I'm going to say total length equals sum lengths of lengths. Okay. And now the value of total length should be the sum of everything, 14. So what that tells me now is each component of my program, each function works correctly because I tested it, I debugged it when I made the error in my initial while loop and accidentally left an infinite loop in there. Okay, I was able to catch that infinite loop immediately because I was only working on that one function. And each of these functions are a few lines. Now, not all your functions will be so short, but for example, I was working with some students on a couple of things. On homework 5, there's a couple of the problems where my function, not counting comments, you need comments, not counting comments, I had a function, that's 5 or 6 lines long because it's doing a fairly straightforward, fairly simple thing. Now, I have built this entire program, working at it a step at a time, testing as I went. I've written the main program, so now, in theory, I should be able to just copy the whole thing. And other than maybe having an error in my main program, this thing should just run. Okay, Doug, Lizzie, Remy, stop. And we're done. So that is an illustration of what I mean when I say test as you go. Build your program, build a function, test it, fix it. If there's an infinite loop in there, fix it right then move on to the next thing. If I had had an error, for example, when I was looking at some lengths, if some lengths gave me the wrong answer, I know I don't have to go back and maybe the error is in this function. I've already tested that function. I've tested that function. I know it works. I can focus on where the error is. Again, don't be upset at bugs in your code. They happen. They can drive you crazy. They make you insane. They're hard to find. You can't figure out why. That's life. Happens to me all the flipping time. You've seen it a few times in lecture. But do this a little bit at a time. Get something working, move on. Get something working, move on. If you can't get it working, don't move on. If you can't get it working, don't go on to the next thing, because that will just cause a problem. So that was what I meant by this part, and I haven't published the slides yet. I'll put them up as soon as we're done on GitHub. Actually, give me just a second. I will do that now if anybody wants to follow along. Download a PDF. Upload the lecture notes. Commit changes. Okay, so this should be the final version of the lecture notes today. As I said, I was editing up right before we started. So this is what I meant by test as you go. We'll do the same with the code. If anybody wants to follow along directly. Upload file. It's October 19th, coding.py. The rest of the files we cover will you'll get access to later on. This is the main code I'm going to run through. All right, getting back on topic. So the next big topic we're going to talk about is reading from and writing to files in Python, because this is a general thing that you're going to do a lot in programming. You don't really often, unless you're writing user interface or what's called UX code. You hear the term UX or UI. UI literally is user interface. UX is user experience. That's the people who write the web browsers, the code you see and type into. Unless you're doing that, you don't really prompt the user for input from the keyboard. You don't really print all output on the screen. Okay? You want to read data from files that already exist, process it, and possibly write data out to other files so that you have it and use it. So what we've done so far is we have an input statement that reads to the keyboard. We have a print statement that writes to the screen, and we don't care. If you've got big data, and we're talking, an event log on your computer system, right? You're running an event log to monitor events on your computer to figure out if you've been hacked or phished or something. You've got a few million to a few billion records. You don't want to input them every time you run your analysis program. You want to keep them in files in a database. You want to read the database, and you want to process it without involving the user at all. It's just a pain in the neck to ask the user to type in the data. You don't want to do that. You can't easily preserve your results for later use for somebody else to analyze. I mean, you could capture a whole bunch of screenshots, I guess, and let people read your screenshots. And I admit that on occasion, I have actually taken my iPhone out and taken a picture of my screen and sent somebody a picture of a screenshot that way. But please don't do that as a normal case of business. It was important to do that. It's a lot better if you have all the data stored in a file that was entered once, either manually or automatically recorded by some other program. It's saved. It doesn't have to be typed in. And it would help if you could save your output to a file that you could reference later on, use for further processing. put into what's called a workflow of X to Y to Z. And Python, of course, like most languages, lets you do that with file input. Now, you can read any file on the computer that Python can find. So I want to go to PyCharm and illustrate. Every computer works just a little bit differently. So I want to illustrate. Now, bear in mind, I'm on a Mac. I can probably show you on Wednesday on my Windows box. I don't have my Windows box booted up right now, but I'll try to make it a point to show you how Windows differs on Wednesday. So this is on a Mac, but it's probably the same. There is something called a Python path. Okay, and it's going to be different on GL. You can find it on GL. If you look at PyCharm, you go into Preferences or Settings. On a Mac, it's Preferences. On Windows, it's Settings. That's the difference, right? So I click Preferences. If you were using PyCharm on Windows, you go into Settings. Then you go into this top item called Appearance and Behavior. Okay, and on appearance and behavior in the settings in Windows, the preferences on a Mac, this part is identical. You see a list of things that you can use to configure PyCharm. You want to look at this bottom one, path variables. Okay, and what will happen in here now, because I've been playing around with this all afternoon, I did it on purpose. I deleted my path. There is a path variable that tells you where PyCharm will go to look for any file you mention. Any file you mention, Python will go, PyCharm in this case, any Python implementation will go to whatever variable is here in the path and look for that file. So the file has to be found on the computer for Python to be able to use it. One thing to do is make sure you have a path variable here and have a value that tells Python all my data files are going to be in this directory. Now, a simple thing to do is always have, if possible, your data file in the same directory as your program. If your data file is in the same directory as your program, almost every implementation of Python I know can find it. Okay. Otherwise, you can try to give it the full path on your operating system. But the bottom line of this is Python has to be able to find it. Now, in today's illustrations, with one exception, one example, I'm going to put my data files in the same directory as this program. This coding file is in a specific directory on my Mac, and I'll talk about what that is in a minute. It'll differ for you, especially if you're on Windows. I am going to intentionally put the data files in the same directory so it will be found. Now, let's go back to the slides and talk about that. Talk about more about how this works, but I wanted to give you the background of what I mean by a Python path. A very common error you're going to have when you run your programs, when you first get used to it, is that the Python implementation cannot find the data file. That's because directory name's not in the path, you're not in the same directory, you're not whatever. That's going to happen. As I said, this varies by operating system. PyCharm on Mac is different from PyCharm on Windows. GL is different. We'll figure it out. Basically, there's an environment variable that can be set that tells Python where to look for any files you reference. The easiest thing to do, again, is make sure your data files are in the same directory you're working. That's what we're going to do today, and I'll give you an example of where it is. Okay. Opening a file. Before you can read from or write to a file in Python, you have to open it. Let's fix that typo. Open it. Okay? You have to open it at the start, and you have to close it when you're done. Open the file, close the file. There are several different open statements in Python. If you really are curious, you can Google around and find them. Stack Overflow has the whole list, all the different ways to open a file. What we're going to use in this class is with, reserved word with, space, open, reserved word open, parentheses, the file name in quotes. I've used double quotes, single quotes at work as long as they match, comma, the mode, parentheses, as, and then give it a file name. And a lot of times you'll just use something like in or out or F or whatever. So we're going to say with, open, the file name, the mode we're going to use this file, the variable name we're going to assign to that file in our program, and then you'll have your code. And of course, since it's in a with statement, just like a while or an if or a for, you're going to have it indented. Indentation in Python is really important, so you'll be indented. Mode. Mode means what you're going to do with a file. If you want to just read from it, it's a data file you're going to read from and process and not mess with the original file. You set the mode to R. R means you're going to read. R plus will allow you to both read from and write to the file. You can modify the file as you go. Now, that's dangerous. We'll talk about why in a minute, but it does support it. W means you want to write to the file. In other words, this is the output file we're going to create. Now, please be aware that when you open a file for W mode, when you open a file for write in Python, Python erases any previous contents of the file. You get a new empty file in Python if you open for W. Now, a lot of times that's good, right? Because you ran your program, you got a set of results, now you're going to run it again, you get a different set of results. The heck with the old results, you don't care anymore. Except sometimes you do care about the old results, okay? So be aware when you open a file for W, in W mode for writing, you will immediately at the beginning, as soon as this statement is executed, as soon as a statement of open it for W is executed, you have erased all previous contents of the file. They're gone. So please be careful about that. If you don't want to erase the previous contents, if you want to add to the previous contents, then just like with lists, there's append. With file writing, there's an append. If you open it for A, you're going to write. You can't read if you open it for A. You can only write, but it will append to the existing file. It will not erase the previous contents. It will write starting at the end of the previous file contents. So if you're only reading, use R. If you're only writing and you want to zap the previous file, it's all gone, that's W. If you want to add to the previous file contents, that's A, append. If you want to both read and write, then it's R plus. We will not in this class be using any R plus because reading from and writing to the same file in the same program is very dangerous because you can erase the contents before you read them if you're not careful. So we will not be using R plus, although Python does support it, okay? R plus is useful if you want to go in and modify certain parts of an existing file. You want to, you got 10,000 lines of data records and you want to change 20 of them. R plus will let you do that. But even then, you're probably better off creating a new file to start with so you don't mess up the existing one. But R plus will let you do that. We're going to be using R and we're going to be using W. Sometimes we'll be using A. Those are the different ways to open a file. Now, I mentioned when you're done, you have to close it. The reason we use this particular open statement in Python rather than some of the other ones is when you use this statement, this open statement, this automatically closes the file when you're done. So whenever the routine that's reading data is done, with this particular statement, the file is automatically closed and you do not have to close the file. If you open file with different statements, you do have to close it. This closing happens automatically, which is why we teach it. It's just easier. You don't accidentally cause problems. So opening a file with open the file name, mode, and then the rest of your code indented with what you do it. Okay, again, you can leave off the mode value. It is optional. If you should not make it optional in this class. It will default to R. If you don't list the mode, you will open for reading. You should probably explicitly insert the R for reading so that everybody knows from looking at your code that you meant to only read from it. Again, using W gives you a new empty file. If it previously existed, any content that was there before will be erased. Using A, again, does not erase existing content. For our purposes, all files are just text. They consist of one or more strings and lines of characters. Everything comes in as a string. Similar to the input statement when you're reading from the keyboard, everything comes in as a string and you have to convert it. Writing is more challenging because you can only write strings, okay? With the print statement, you're writing to the keyboard, as you've learned, you can write strings, you can write integers, you can write floats. We've given you some formatting tools, F strings and the like, to control how many decimal places you print out, all that other stuff. With files, you can only write strings. And we'll give you some examples of what you can't do as we get toward the end of this lecture. So, strings read in, strings write out. There are in Python what's called binary files where we're not reading strings, we're not reading text characters, we're reading, some UTF-16 or UTF-8 values, and there are all kinds of funky emojis and what have you. We're not going to talk about binary files right now in Python because they do weird stuff that takes a lot to explain. For our purposes, they're just text. All right, an example, and we'll do this in a minute. With open testdata.txt R as F. The file name testdata.txt will be in the same directory. We're going to open for reading. We're going to call it F. What this means is F is the variable name. In the symbol table, F is the variable name that's associated with this file. Now, we can read in data three ways. We can say f.read. F.read reads in all the data from the file as a single string. Or we can say f.readlines, which will read all the data from the file as a list of strings. Each line of the file will be a separate string in the list. So this lets you read in everything as a single string. This lets you read in everything as a list of strings. This command, read line, and yeah, it can be confusing, I agree. Read line versus read lines. Read line reads in one line from the file as a string. So if you want to read in one line at a time and process it, you use read line. If you want to read everything at once into a list of strings, it's read lines. If you want to read everything into a single string, it's read. Now, let's go to PyCharm and point out a few things. Okay, just to illustrate, I created the data file beforehand, testdata.txt. I put it in the same directory on my system as the Python program to make it easy. Okay, this is a silly little data file. It's all text. It's a text file. We use it for practicing reading in data from files. It's 4 lines, all strings. Okay, fine. Nothing fancy there. It's just plain text. Because it's in the same directory as my program, I can just say open testdata.txt. Okay. I'm going to open for reading. Again, I could leave this out, and Python will default to leaving to reading, but I don't want to do that at this point. I want to explicitly say I want it for reading. And again, this is my variable name as f. Now, initially, I'm going to use a data equals f dot read. I'm going to read everything in as a single string. Okay, and so we're going to see how this works. Okay, let's just copy the right thing. Here we go. All right, now I read everything in as a single string using this command, data equals f dot read. The rest of the stuff's commented out right now. It's not operable. Data equals f dot read. So let's look at the value of data. You'll notice that data is a very long single string. This is a text file. \n, remember, is a new line. This is a new line character. That's what Python put in every time it hit a new line, an end of line in my data file. Python read in a \n for a new line. Okay, that's what this f.read did. So Python says I now have a single string. This is a text file, \n. We'll use it for practicing, \n, reading in data, \n, from files, \n. Everything came in as a single string. Okay. Now, what do I do with this single string? Well, that depends on what I want to do with the program. So maybe I want to read in everything as a single string. Maybe I don't. We have to figure this out. One of the things I can do, remember split. The split command breaks apart the string into a list of strings, and I can tell it what I want to split on. So if I say line list is equal to data.split on a new line character. Now I can see I have a list of strings, and each string is one line from my data file, and now I have a list. But of course, if I didn't want to do that, if that was what I was planning to do, then I probably could have just, I'll comment that out, uncomment this, and now I'm going to use read lines. I'm going to read all the data from the file and return a list of strings. Each element in the file is one list from the string. Okay, very good. There we go. Take that out, uncomment that, and execute. And now what I want to see, the line data is meaningless. That was commented out. I want to look and see what data lines is. So I come down here and say, what's the value of data lines? And I see that I have a list of strings. So this is the same thing that I got from reading everything into a single string and then splitting, except that here the new lines, the \n, are actually part of the string. So I could use this. I could use read and then split and accomplish essentially the same thing, although here, if I care, I may have to get rid of a new line character. That's fine. That'll work. This reads in one line at or each line as a separate entry in the list, a separate string in the list, as opposed to above where we read everything into a single line, a single string. It didn't care about new lines. Now we'll figure out how to read in one line. Now, the same thing, I have the same code, the same file, and I'm going to read in just the first line of it. What is the value of next line? Next line just has the single line from the data file. So I would probably wind up putting this in some kind of a loop, a for loop or a while loop or whatever, probably a while loop. And read in one line of data at a time and process it. That way I don't have to put in a list. Which one you want to do I believe that all programming problems I've run into, certainly that we're going to deal with in this class, you can do any of these three. You can do read lines, and you can do read line one at a time in a loop, and you can solve all problems just with whichever one you want to do, whichever one you want to use. So we will use all three at different times because one will be easier than the other. But every problem I've run into, you can make any of those three methods work. Any of the three are fine. You can use whatever you prefer, unless we, for example, specifically tell you otherwise. Okay, let's talk more about this file name. Now, what would happen if this file did not exist? I'm going to switch to a terminal window on my Mac. Right now, that's what you can see. This is the Python terminal in PyCharm. And you can see, just like on GL, this is a Linux command, a bash command. It's actually a Z shell command, not a bash command. But it's the same thing. pwd says print working directory. Where am I right now? I am in my directory on my Mac /user/AlfredArsenault/PyCharm project /fall 2020 project. That is the directory in which I'm working right now. Okay. Just like on GL, I can list what files are in this directory. Okay. And I will see that the file testdata.txt is indeed in this directory. So this will work. You can go into a terminal in PyCharm. If you're getting an error that says a file doesn't exist, let's go back to a console. And let me change this to deliberately have an error. I'm going to take out the E. So I'm deliberately misspelling the file. The reason I'm doing this is I'm going to show you what happens when this file doesn't exist. I misspelled test. There is no TST data in my file. So I come down here, and when I try to run this code, I get an error message that said, no such file or directory, tstdata.txt. Okay. In this case, that's an error caused by the fact that I deliberately mistyped the name. To illustrate. But quite often this will happen because you're in the wrong directory. Okay. And you might not be able to figure out what directory you're in. Well, one solution you can have, and this will work, is you can give the full directory, the full name, the full path on your system of this file. So I happen to know on my Mac that I'm in /users/AlfredArsenault /PyCharm project / and spell this correctly. And this is actually, I missed the directory. This is fall 20 project / Now, let's go back and check one thing. It's fall 2020. This is where terminal comes in handy because, again, on the terminal, pwd, users, AlfredArsenault, PyCharm projects, fall 2020 project. Let's make sure I have that correct in the full path name. Fall 2020 project. Okay, what did I misspell? Let's see, what did I misspell? Okay, users, AlfredArsenault, PyCharm project, fall 2020 project, testdata.txt. Go back to terminal. Projects has an S. That's what I didn't do, okay? If you don't want to have to keep going to the terminal to find out what your current directory is, here's a little cheat you can use. This is okay in the Python console. If you're trying to run things to debug them in the Python console, there is a set of routines in a library called OS. OS is short for operating system. Okay. And they have different routines for different systems, but basically it'll figure out whether you're on Windows, Macs, or Linux. You import OS. Import OS gives you all the routines that deal with interfacing with the operating system. And so now I will say OS dot, the routine I want to use, the function I want to use is get CWD, and it gives you some examples right here. It gives you the code. Get current working directory. So this is the same thing as PWD in the terminal in the Python console in my code. This gets the current working directory, and it's the same thing. So now I can come back to this data, to this code, and now, since I know what I'm supposed to do, I can say, well, I can give it the full path /users /Alfred Arsenault /PyCharm projects /fall _2020 _project /test. And now this should execute. Okay, and since I'm back to reading the whole file, I look at the value of data. So, key things to look out for when you're doing I/O from files, because it's a very common issue, is list, either put the data file in the same directory as your program, so you don't have to give it a path name. You can give it the entire path name of your system. This is the format on a Mac. Okay. Or you can rely on that path variable, which we'll talk more about on Wednesday when I show you how I have my Windows box set up. But the bottom line is, if you get a problem that the file cannot be found, it's likely because either you mistyped the name, check on that, or the file's not in the right directory. It's not in the place where you thought it was, in which case you simply have to figure out how to get it in the right directory or give the path. So that's an example of reading in data from this file and then manipulating it, doing read, where we got the whole thing as a single string we could then split and do other things with. Read lines, we got a list of lines that had the new line characters on it. Read line, let us read one line at a time, and remember, everything is a string, just like reading from the keyboard. Okay, I want to go back to the slides to show you what I'm going to do with this next piece of code where we're going to read from another file, okay, integers.txt. So let's go back to the slides. Let's talk about the file pointer. Yeah, before we get to, what have I got next? What's the next slide? Integers is my next one. Yeah, let's talk about this one. Okay. How this works behind the scenes, and here's why the difference between write and append. For any given file, whether you are reading it or writing it, there is a file pointer. The file pointer points to the place in the file where the next character is going to be read from, if you're open for R, or the next place, the next item will be written if you're open for W or A. So the file pointer says this is the next character that's going to be read. This is going to be the next character where this is going to be exactly where I write the next character that's output. You open a file for reading, the file pointer starts at the beginning of the file. If you do read or read lines, you consume the entire file. The file pointer reads in everything and goes to the end of the file. You're done. If you do read line, the file pointer goes to the start of the next line. It consumes the /n, the new line character. It doesn't. The file pointer doesn't stop at the new line character, but that new line character is gone. It's read in. If you do read line, the file pointer is advanced to the start of the new line. If you open for writing, for W, the file pointer starts at the beginning of the file, and that's why everything that was there before is gone, okay? The file pointer is simply going to write over everything that was already there because file pointer is put at the beginning of the new file. Okay. When you open for appending, the file pointer goes to the end of the current content and will start from there. So you will not overwrite the thing. Now, you're not going to have any questions. You don't have to know anything about how the file pointer works. This is just stated as to how behind the scenes Python manages this. The bottom line is there is a pointer that Python manages for you that says this is the next character I'm going to read, or this is where I'm going to write the next character. And it starts at the beginning of the file when you open for read or for write. It starts at the end of the file when you open for append. You open for R+, it also starts at the beginning of the file. But as I said, we're not going to get into that. Okay. What I want to do now with my next bit of code is I'm going to read a file in. I'm going to find the largest integer in a file full of integers, and I'm going to print it out. Okay. Now I have this case where I'm going to print it to the screen, and then I'm going to go to this case where I'm going to print it to a file. Okay. This one actually has an error in it, so we will get to that in a minute. We will talk about that. Let's go to PyCharm and illustrate exactly what is happening. So here is the code I have in the slides. With open, integers.txt. Again, integers.txt is a text file in the same directory as the program. I'm going to open it for R, and I'm going to call it F. So the variable F is going to get reused. It's no longer going to point at testdata.txt. It's now going to point at integers.txt. Integers.txt, you can see, is just a file I created. It has 3 lines of integers on it. We're going to read these in. We're going to compare them, and we're going to print out the largest. And you should be able to see very quickly that the largest is going to be 352. This is a nice little data set to test the code to make sure that it works. Because if the routine read in this file and told me that the largest value is 1, I would know that's a bug, and I would know I'd have to go fix my bug. Okay, so I start with a data file that gives me an easy way to test and say, okay, clearly, this is the only thing that's 3 digits. This is clearly the largest number. My code better tell me that this is the answer. So let's go back to today's coding file and this routine. To show that integers.txt is in the same directory, I will go to my terminal and I will look and see. I'll do it again just in case. You will see that integers.txt does indeed exist in this directory. So this should not be a problem. This should work properly. Okay. I'm going to read in the data. With a read statement, I'm going to read in all 3 of these lines as a single string. Now what I'm going to do is I'm going to split on white space. I'm not going to split on new lines. I'm just going to split on white space. Remember that white space is these blanks between the numbers, and the new lines are white space. So what's going to happen is I'm going to have, by the way, the slides have all the comments. When I was running the code, I took the comments out to make it a little easier for me. So don't worry about that. The comments are all in the slides if you're having trouble following along, or just ask me and I'll explain. I'm going to split this, and then I'm going to have a list, and I'm going to have this as a string, and then this is a string, and then this is a string, and this is a string, and so on. So read in everything as a single string. Split it on white space. I now have a list of strings. Now, what I have to do is convert each of those strings to integers. So the way I'm going to do that is I'm just going to run a for loop, and as this for loop is going to go over my numbers as my list of strings, I'm just going to go over my list of strings and convert each value, each string, into an integer. So when this for loop finishes executing, I now have a list of integers, and now I can work. Okay. Now I have to find the largest, and the way I do that is I initialize largest to the first number. Okay, the first value is tentatively going to be the largest in my search. I don't want to set largest to something arbitrary like 0, because what if every number is negative, then largest really is 0. Okay, I don't want to mess things up. So I'm going to say initially starting out, the first number is my largest. So my first number is 1. Number sub 0 is 1. And now I'm just going to go through and I'm going to say if the next number is bigger than the largest, then that's the new largest. And then we're going to print out, again, initially I'm going to print this out to the screen. Okay. Okay. So let's copy this. Let's bring it down to a console and paste it. And let's run it. And yay, verily, it worked. Testing as I went worked fine. It gave me the largest integer of the file was 352, which we knew from looking at our data that this was correct. So what we've done is we opened the file, we read it all as a single string, we split the string on white space to get a list of strings. We then had to go through and convert every string into an integer. And then we had to run a routine that went through and found the largest number. And then it printed out to the screen what the largest integer was. Okay. That let us work with existing data that's in a file. Okay, how am I doing on time? 20 minutes. Good. Still lots of time. Okay, I had to know that this file existed. I had to know that this file was in the right directory. If it was not, as we saw with the test data.txt, when I gave it the wrong name or when I put it in the wrong directory, I got an error that it couldn't find the file. My program crashes. Okay, so I have to check it. Now I want to, instead of printing the results to the screen, I want to write the results to a file. Now I'm going to, since I ran this to debug it earlier, I'm going to get rid of my previous file. And we notice, nothing up my sleeve, there is no file called results.txt. That file does not exist. And that's important for writing for the following reason. Now I want to try, instead of printing the results to the screen, I want to write the results to a text file. The results are going to go into a file I'm going to call results.txt. Now, I just showed you, nothing up my sleeve, full disclosure, there is no such file. But because we're open for writing, it does not matter. If the file does not exist when we open for writing, Python will create it for us, and it doesn't matter that it doesn't exist. Opening for appending, if I had opened this for A, that would also be the case. If I try to open a file for appending and it doesn't exist, Python says, no problem, man, I can handle that one. It just creates a new file. So if you're reading from a file and it doesn't exist, your program crashes, you get this horrible error message, and now you got to go fix it. If you open a file for writing and it doesn't exist, Python goes, that problem I can handle. I know how to deal with this. I'm just going to create this new file out of nothing. We're good. Okay. Remember that because if the file did exist already, its contents are going to be thrown away. The designers, the writers of Python said, well, there's no difference between throwing it away and starting fresh and realizing there is nothing and starting fresh. So that's why it works this way. When we do the with open results.txt W and that file does not exist, and I just showed you in the terminal, it does not exist, then Python says, I'll just create it and we're good to go. Now, when you write to a file, you can only write a string. Each write can only write a string. Now, you can put in a loop that can write more than one string at a time. You can only write a string. Okay. So look at this. This is what I had in the print statement, right? The largest input in the file was plus largest, string concatenation. This is the moral equivalent of this statement that I had in my print. But I cannot write that directly to a file because that Python thinks is not yet a single string. It takes string concatenation, but if I tried to write what's highlighted in a write statement to a file, it would give me an error message because Python says that's not a valid string. Okay, so you can't do that. So what I have to do is I have to create a single string, and I'm going to call this S. This statement takes what I wanted to put out there and writes it in and makes it into a single string S, because S is now a single string, and a single string I can write. Now, the with open statement, I said out is the file name I'm going to call this results.txt. So it's file name out.write. Just as up here in the read, I called the file F. F was the variable for the file name, and I did f.read. Down here, out is the variable for the file name, and I did out.write. I opened for write. I'm doing out.write, and I want to write the string S. So in theory, if I just copy this and paste it down here in my Python console and run it, I knew there was a mistake I hadn't fixed. Largest is an integer, and you can't concatenate an integer to a string and get a string. That's what this is supposed to be. Sorry about that. Again, by isolating where the error was, I made it easier to debug. Copy, try this again. Here we go. There we go. This now works. Now, let's go over to the terminal. I'm in the same directory. And look, results.txt is back. Okay. Python created results.txt. Okay. Again, by default, it's going to be in the current working directory. Whatever Python thought is your current working directory here, that is exactly where Python is going to write this file. So you look at this, that tells you the directory that Python's going to write this file. Let's go over to the terminal. Let's look at the, let's do a list of the files in that directory. And lo and behold, there is my result. There's my results.txt file. And if you go back up above right here a minute ago, it did not exist then. So Python created it. Now let's look at the contents of it. So we know from Z shell, bash, whatever scripting commands, that's just a cat. Cat results.txt. And results.txt has the largest input in the file was 352. And since I didn't have it print a new line, now I get my command prompt. This parentheses base is just part of my command prompt in the terminal, as you can see. This is what the contents of the file are, and I didn't put a new line there. And so there we go. Now, if I wanted to fix that problem with the new line, what I could do is come back up here and concatenate plus string of the largest plus \n Now let's go over to the terminal. Let's cat results.txt. We know it's there. It's written over. And lo and behold, because I had a new line put on the string, the new line got printed, and that made it a little bit easier to read because I didn't get my command prompt right on the same line. So that was just the result of appending or concatenating a new line instead of just leaving it off there. And that's the end command will work the way the end command works for the write, the same way it works for print. And so you can do that in formatting. So this is something that you use when you do what's called pipelining or chaining or workflow. Has a lot of other names. You write a program that reads from a file and it creates the results and it puts the results in a file. Now somebody else's program can take that file that you created and do something with it. Or you can even do something with it later on in your program. If your programs get more and more complex, what can happen is you can read from a file, an initial data file. You can create a data file in the middle that has processed results, and then you can use that in your own program later on. Okay? You close the file for writing, then you can open that same file for reading, and in your same program, you can then use that as a file to do some more things. And that's called, as I said, depending on who you talk to, that's called a pipeline or a chain or a workflow. I have an initial data file. It's all the logs from sysmon on my Windows machine of all the events that can happen to see if I got hacked. I write a program. It analyzes all my records, but first it needs to put them in a reasonable format so I can do something with it. So I read in all my sysmon logs and I process them and I create an output file that has the records that I care about in a format that I care about. And then I can write another program, or somebody else can write another program, or I can use a commercial or open source program, and I can process that file, and I can get something that says, yes, you indeed have been hacked. You've got this problem. You're part of this botnet now, or whatever. Okay. This is pipelining or chaining or workflow. It's going from step 1 to step 2 to step 3. And this is when we have all of our data. We create output files. So we'll do some things with programs where what we'll do is have student records. So what I will do, for example, for project 1 is I will give you a bunch of student records with scores, though they're not real students. They have names like Howard Wolowitz and Sheldon Cooper and Amy Farrah Fowler and the like, and it has their test grades, and you will read them in from a data file, and you will do some list manipulations, and you will come out with a class ranking and grades and things like that. We'll talk about that more on Wednesday, but that'll be what you're doing. You're going to read in data from a file, you're going to process it, you're going to do something with it, and then you're going to write it back out to a different file rather than just putting it on the screen. You can, of course, do both. I could delete this comment, and we could both print the results to the screen and print the results to the file. There's no reason we can't. Often what we'll do is we'll print status messages or error messages to the screen and final results to the file, which will let the user know there's a problem here. But it doesn't matter. You can do whatever you need to get the task done. So that's a case of how we read data in from files and write them out. So that's a start. So let's see, what did I have else on the slide? That was this one. Yeah, as I said, this one, the slide had an error. What I put in there is the correct version. I'll try to make sure I get that updated so you have the things. Reading and from and writing to the same file. All right. Here we go. I want a file that has some data. I want to replace every occurrence of the word dog with the word cat, and I'm going to write the modified data back out to the same file we started with. Careful how you do this. You don't want to erase all the data in the file before you finish reading it. So I've got 7 minutes. I think I can do this. We're going to find out. I need to create a new file. It's going to be called dogs and cats dot text. Sorry. .txt. All right. Okay, dogs and cats.text will look like the following. We are looking for the word, what did I say in the slide? Change cat to dog? Yeah, change cat, dog to cat. We are looking for the word dog in this text, and we are going to replace dog with cat. Dogs are not good. Dogs are wonderful. Dog, cat, dog. Here is our data file, and it's called dogsandcats.txt. So let's go back to today's coding. I'll get this up to GitHub. It's in the same directory, open. I'm going to open it first for reading. Dogs and cats.txt. For reading as F. I'm just going to read everything in as a single string. The reason I do this is because now I have read everything in. Now I can write to the file, but I won't have to worry about losing anything. I can't lose it because I've already got it. Now, I have a single string. I need to make that a variable, okay? So content equals f.read. Okay, content is a single string with everything in it. Now, I need to change that into a list, so I will call it content equals content.split, and I just want to split on white space so I get the list of words. Okay, now let's just run that code and make sure it works, because there's a really good chance I messed something up. It's been known to happen. Okay, yes, it's called dogs and cats.txt. Let's try this again. Okay, and now if I look at content, that was my text as a single string. Now I look at contents, and I have my list. Now what I need to do is go through for word in contents if word equals dog. Now, here's my problem. I am not going to match on the plural. If it says dogs, it's going to say dog. It's only going to change it to cat. If it says dogs with an S, it's going to stay dogs. It's only going to change singular. That's what the assignment says. Word equals. No, this won't work. Sorry. I need to do the other thing. What I'm going to do is I'm going to build a new list. New content. How is it? Still got 2 minutes. I can pull this off. For word in contents, if word equals dog, new content dot append cat, else new content dot append word. Okay. Now let's see if that works. Okay. All right, I'll fix this later. Gambling too much trying to pull it off. Anyway, the bottom line on all this is I'm going to build everything into this list called new content.append. Then I'm going to use join to create a list of strings, a single string or a list of strings. Then I'm going to open dogs and cats.text for writing, which will delete the previous contents. And then I'm just going to do out.write the results of the join. So you really can, and I'll wrap this up. I'll actually post the code later tonight that works as soon as I fix that bug. And then we'll talk about it briefly on Wednesday before we get into some more complex operations and talk about the program. The bottom line is what I'm illustrating is you can indeed, if you want, use the same file for reading and writing. You open it for reading, you read everything in, you manipulate, and then you open the same file for writing. And you just write to it. And now the file will have the same file will have the new contents with everything done. Straightforward. And I'm out of time. So I thank you all for your patience. I actually ran 1 minute over. I really appreciate all your patience. I know that for a lot of you, I'm getting feedback and I appreciate it. I'm here to help. You didn't sign up to come to UMBC to take online classes, and you really wish you could be in the classroom. And trust me, I really wish we could be in the classroom too. So I thank you for your patience and bearing with me. And let me know how we're doing. If you need help, let me know. I will get the updated code out to GitHub, and then on Wednesday we'll talk about this some more, and we'll talk about programming project number 1. If anybody has any questions, I can stay on for a couple of minutes. Otherwise, thank you, and I will talk to you on Wednesday.